Hello guys and welcome back to this tutorial series. For now we have reached the schematic editor, which is one of the most important things that you can ever use in a PCB design project. Now if you remember, our project began with this very simple kind of project just for demonstration, and here it is. Revert back to lesson number 2 if you still didn't follow that. Please follow that first and then return to this tutorial episode. And before you start, please like, share and subscribe. It really helps the channel. Go to thundertronics.net and Thundertronics store to check my stuff. And with that out of the way, so let's get started. The schematic editor is very simple, as you can see. There are icons in here and icons and tools in here. We're gonna go through all of them right now. This window is called the schematic hierarchy. So this here tells you how many pages of your schematic sheet that there is. Because guys, remember, this is a sheet after all, more like a book. And this is the working area that we will be working on. I can zoom in and out by the mouse button. Here we have the drawing tools, the stuff that I use to draw stuff right in here. And these are other tools that are mainly for maybe outputting stuff, checking stuff. We'll go through all of that. But before doing anything after saving the project is actually first go to the schematic setup, because I want to set up the things that I'm doing right here for first and foremost. First of all, go to the formatting, check if you need to change something like the text size, the whatever. I just leave it to basically default. Go to the electrical rules check, because we will be checking these. Here are stuff more like rules and conflicts. For example, if you go to this, the connection pins are not connected. What happens when that error occurs? It will give you an error. It will be listed as an error. But for example, if unconnected and no connection flag, it will give you a warning because the circuit will still work. Now, sometimes you can just maybe ignore some of them, make them an error instead of a warning if you care about that. But basically, the defaults are absolutely fine. You can check all of these, of course, and but basically we always use the ERC, the electrical rules check. Now we go to something called net classes in our project. Now, it will tell you there is a default net class. Now, what is a net class? It is an electrical wiring scheme specifically made for a certain amount of traces, for example. By example, I'm gonna make a new one and I call it power. Okay? So, the thing that I call power, the net class that I call power, I want it to be 0.5 millimeters. Okay, and bus thickness, I don't care about bus thickness. The style maybe something like this, and I hit OK. And you go here to all of these options. Not really that important. If there is an embedded files like fonts and stuff like that, you can basically do them right here. But most importantly is the size and the net classes as well as the ERC. Now I'm ready. I'm gonna press OK. So now I'm gonna save the project. By default, we only have one page, which is like this, the size that you have selected. But what if you want other pages? Now, KiCAD does not allow currently what we call a flat design, which means the pages are all in here, lined after each other. But rather, every page is displayed by itself. Now, what do I need to make a new page? We will go through that right here. But basically, let's go through the top shelf first. This is the save icon, pretty sure you all know that. The schematic setup, we went through that. Page setup. Okay, this is the page setup. What type of page, etc. What type of revision, title, these stuff that's gonna go right here. Okay, you can basically play around with that. Basically, I don't really care because I'm not gonna really print out the design. I'm just gonna keep it on my PC. And these are print and plot. Plot will go through that later on when we do the PCB. Basically paste, find and replace, refresh in case you do that. These are the zooming tools. We basically don't really care about that because we will be using the mouse wheels and the shortcuts. Navigating through the sheets, maybe the hierarchy. If you create sheets and sheets within sheets, you can move in these using these arrows. Not really that much used. These are for flipping and rotating, mirroring the items, just like this one. I'm gonna make it maybe a rotate or mirror, something like this. Undo. But these are also gonna be used by the hotkeys. Now this one is the symbol editor. I briefly explained what the symbol editor is in the previous tutorial, and this is not the video for it. Basically it makes you edit the symbol itself rather than just using it. Symbol library browser, we don't need that because we will be looking for items in another way. The footprint editor, exactly the same as symbol editor. I explained that in the first video, but it's for footprints. This one is annotation. You can basically, let's move it right here, to annotate and maybe make it annotation completed. Basically annotation is like this: C4, C3, U1, J2, J3, J4, C5, C7, basically giving everything giving everything an annotation. This is very important. But when you add this, if you add another J, for example, it's gonna have a J2, which is like this one, and J3. So you don't really need that, but you can clear all annotation and start from the top, basically. Now here, it tells you that you want to annotate the entire schematic or the current sheet only, or this maybe if you selected something. And the sort of annotation, if you want it to go from top to bottom, then to top, then to bottom, or by going basically from here to here horizontally, then go to the next line. So if I go from top to bottom, this is gonna be J1 and it's gonna continue until it finds J2. But if I have another J right here, this will be J2 and that will be J3. But if it went horizontally, it will be opposite. Not really that important, but some people some people do enforce a certain way of naming stuff. It depends on how much of perfectionist you're gonna be. Don't really matter that much. The electrical rules check, very important. Now we already established the rules. Of course, we don't want anything unconnected. For example, we don't want to forget anything. So I'm gonna say, please run the electrical rules check. It tells you that there are 0 errors and 0 warnings. Okay, in case you made an exclusion in the rules, it will tell you that. Okay, what are the ignored tests? So these tests, we just ignored them. Maybe if a certain part have an issue in its SPICE model, I don't care about that because I'm not gonna simulate it. I just want the PCB to work. So before you jump into the PCB, of course, you're gonna run the ERC check. You're gonna see this nice little 0, which is green, and hopefully no other warnings. But if it did, you need to tackle them. So let's make one, for example. Let's make something like this. This is now not connected. I'm gonna save it. I'm gonna say run electrical rules check. Now I wanted to show the errors and the warnings. It tells me that a warning, or maybe start with the error. The error, you see, when I press like this, it tells me that this red arrow is the error. It tells me that this one is not connected. Okay, and here the warning, it tells me that I have started a wiring, but it's not connected to anything. See, this in of itself is not really an error, but maybe you forgot something. That's what KiCAD was trying to tell you. So now I'm gonna, do this and save, but I'm gonna create something like this, an empty wire. Let's see what's gonna happen. Yes, 0 errors, but it tells me that this wire is not really connected. I can basically come here and delete this thing, save, run ERC again, and absolutely fantastic. Now we go to the next one, simulator. I don't use that. It's a whole another subject. Assign footprints. KiCAD doesn't work like other software. Other software, when you choose J2, for example, you already choose the footprint and the part that you're gonna use, most of them. In KiCAD, no, you're just gonna use J2. If it has an attachment, if it has a footprint already attached to this symbol, then so be it. But if it doesn't, maybe something like this USB micro B connector, maybe it doesn't have maybe it's a generic connection like this J2. It's a generic connection. Okay, so it doesn't have a footprint. How can we assign the footprints? We can use them from here. So you're gonna go through one by one. For example, this capacitor. It highlights the capacitor right here. Let's go back. It highlights C1. It's 100 nanofarad, and I already chose the 0402. And these are all the footprints available for capacitors. Let's go to this one. This one is a polymer or electrolytic capacitor, polarized. All of these are available footprints, not necessary part numbers, just a footprint. And we go to the USB micro B, all of these, but I already did that, and this is what I recommend. Maybe you can leave them to the final final stage if you are really that much unsure. Maybe you want to use 04, 02 capacitors, or 06, 03. Who knows, right? You can leave them and just assign them right here. And okay, you can use this one, the voltage regulator, and you can see I have chosen a generic IC footprint for it, which is this one, SOT TO 252-3, tab pin number 2. You saw that, because this one, this particular part number can come with anything, can come in SOT 89, I guess, or SOT 223, or TO 252, and the middle pin is not really connected, but it's connected to the mid tab. I can, because I know exactly what I want, I have chosen this particular footprint. But again, I advise, the best practice is to never use this massive bulk assignment, but rather work step by step and be someone who knows what exactly the footprints is he gonna use for his boards. Once you finish, click apply, save, and continue, and then okay, Control S to save, and that's it. And let's go for editing this symbol, for example. Press E to edit. We previously talked all about this. We forgot to do something that is very important, which is the footprint. You're gonna press this symbol right here, and all of the footprint that you have in your footprints library will be around this. Now notice I have opened a library called package TOSOT-SMD, and I went through, because I know this part has this kind of SOT 223 and SOT 89, for example, and SOT 263. It has all of them, and I have chosen this one in particular. I press OK and save, because the generic symbols like this one will not come with a footprint attached. Maybe something like a capacitor will not come with a footprint attached. So either you choose the footprint, the assignment footprint right here to bulk assign them like we talked before, or you choose the method that I have shown you now, which is the manual mode, and this is more accurate, and you will remember everything that you have chosen, and so on. And maybe do a last check using the footprint assignment tool. And basically next one is edit symbol fields. Now this one and the other one, which is generate bill of materials, are already in the same category. So both of them, I consider both of them the same thing. So these are called the symbol fields. Let's get back to one of the symbols first. Let's get back to this one. Press E to edit the symbol, and you can find the fields. Now here are the fields. Reference, I call it C3, value 100 nanofarad, the footprint, datasheet if you want to, description, maybe you can write it, part number, and I can maybe add another field. I call it maybe alternative part number. Right? Maybe I can do that. And I can fill it right here. I can fill the part number, I can fill the alternative part number. And I say, okay. Now, once again, we can show these fields on the schematic, and maybe you can align them and maybe just do all of these basic stuff. Now, when you go back to this one right here, it gives you everything that you have, like all the symbols that you have, with everything, with every field that they are showing. Now, here are the available fields used by my components, and which one do I need to be available or visibly available here. And let's, for example, I want to delete those. I don't need them. I don't want the data sheet. I just want the value, the quantity, you see, something like this, and the footprint. Okay, but I want to add a part number. Let's say add a part number. That's a part number. Let's add alternative part number, because I added it to one of the components. Now I can add it for everybody. Now once I apply and save, maybe I fill all of these once I'm ready to just basically finish the project. I want to generate what's called a bill of materials. I really need these part numbers. I really maybe add another field. I call it maybe supplier one link, for example, and it's up there, it's available, supplier one link, and basically fill all of these. Once I continue to save and continue, I can go to the export, which is the bill of materials, and I can say maybe export the bill of materials. Okay, and let's go here again, and we forgot to make export. Okay, it's outputted to the project directory. But let's get back again. Here we have the preset. Maybe not every project that you're gonna make, you're gonna start organizing this all over the place again. Maybe you can basically save a new preset. If you like this, you're gonna save it by a new preset. I saved something. I gave it maybe default editing, maybe something like this, or maybe not, attributes. See, all of these are presets. You can use them, you can save them, but maybe default is the one, and you make your own and save it. Okay. And the last button right here is something that gonna move you from this schematic editor to the PCB editor, which is the tutorial next week maybe. Okay, I moved to the directory where I saved my project last time, and I have opened Microsoft Excel, then from text or CSV file, and we go to the project directory and we find them. Now this is the first one was right here in the previous tutorial, and I'm gonna choose this one because I made it just right now. And as you can see, it's opening, and now all the fields that you have chosen are there. You can basically say load, and that's it. It loaded all of your values, and you can basically organize them the way that you want and submit this to your PCB manufacturer. Okay, getting back right here, let's start actually designing something. Here are the tools that you can use in the working area. This is the pointing tool, maybe selecting items like this. This is a highlighting tool. Maybe I want this 3.3 volt rail to be highlighted. Now it highlighted everything that's connected to it. When I highlight ground, I see everything that's connected to ground. It's more a visual tool, not really important. This right here is one of the most important things. You can place a new symbol and it loads every library that you have. So for example, if I need something like a 0805 regulator, maybe I can search for it here, and I can basically double click and place it. Notice that it uses U2 now symbol instead after U1. And you can basically search for resistor, for example, r small us, which is another symbol rather than the other. Maybe grab something else, maybe go for a inductor, maybe L, this is an inductor, and so on. You get the idea. This is a power tool. It places power symbols. Go here and press, maybe you have 3.3 volts, the thing that I chosen. If you have something else like 5 volts, you can find it here, 10 volts, whatever, minus, all of the power symbols, grounds, all sorts of grounds and stuff like that. And maybe something else I want to show you, which is the power flag. Where is this thing? This is the power flag. The power flag is sometimes KiCAD cannot recognize what you want to do easily. Maybe it doesn't see that this is a power symbol or a power rail, and it gives you an error. You can basically put a power flag and attach it to the rail. Let's see if it gives us any problem. Yes, it gives us, it tells me pins of type power output and power output are connected, because this is a power output and this is a power output. So in this case, power flag didn't work. We don't want it. But basically, please make sure to remember the power flag whenever you have a power issue. Maybe you can assign it to other rails which has a problem. Okay, moving on. This is a draw tools, which is the letter W. I can press right here W. Now I'm gonna like draw stuff. Once I'm finished, double click, it's right there. And I can maybe, if this is not connected like this, I can hover and it will automatically start. By pressing, it will start doing so. Now I can also drag this, it will also be organized. This is the same as this one, but it's for buses, not really important for this tutorial. And these are also the buses entry wires. Also I saved them for another advanced lesson. This is called the non-connect. Maybe if you go to here, I don't want to use USB features, I just want the power symbols. If I leave them without anything, it will tell me an error, but I need to put this on this pin. For example, let's move, let's say it doesn't exist like this. Run. It tells me this thing is not connected, but I don't want it to be connected, so I put not connected and save. Basically, that's it. This is placing junction like this. Not really important because you're already gonna use it when you draw. And this is also called net labels. Now it's also really nice if you label stuff. In this power supply, simple power supply, we have this rail has 5 volts and this is 3.3. So these rails already have a label and this one already have a label. But if you want something else, you can basically put something like power output like this and assign it to here and then wire it up. Now you assign this label for completion. Now you go to this global label, is the same as this one, but this global label works on all sheets. Now this one here only works in the root sheet that we have, but maybe if we have multiple sheets, if I put power label in each one of them using this tool, it will always be local, but this is gonna be global. Maybe professionals don't like to use global too much, but I don't really care. Both of them are nice, and you choose basically what's working for you. This is called a directive label. I'm gonna explain it later. The same thing with this one, and also the hierarchical sheets. Let's start by doing the hierarchical sheets. I have maybe used all of this space and maybe I want to organize stuff better. I'm gonna use another sheet. Let's draw another sheet. Let's call it other. stuff like this, and the file itself on your Windows is gonna also called other stuff, which is I recommend. Okay, so now if you look right here, we have another sheet deep inside. Double click, now you are also joining this sheet. You can basically write whatever that you want, and basically you can return by pressing here, or maybe going forward and backwards like this. If I'm here, I'm gonna move up, and basically just use the hierarchy navigator. Now if you go to this hierarchy sheet and maybe you place a hierarchy label, call it for example other stuff out, for example, and you hook it up to basically a lot of stuff right in here. Now you go back right here, you place this, and now see, now you can connect anything in here to this hierarchical sheet, and when you move it will be connected to this guy right here and basically make your way in. So if this, for example, a signal from here is going out and it must go to the sub-circuit of this schematic sheet, I create first of all the pin using this inside the sheet that I want, then get back up and press this one, place sheet pins, and put it right here. Very simple. It's just routing stuff. But of course, if you need something that is more easy, you can use the global labels. But when you have like multiple sheets, it's gonna get messy. But this stuff, it's gonna get complicated when stuff gets bigger. So use it with your caution. And basically, to every engineer his own ways. Now sync sheet pin. Okay, maybe you check it on your free time. I never used this tool before. And of course we have finished this. Now here you can basically write a text, basically something like main sheet, for example. I'm gonna use it like this. Okay, maybe I can write stuff here. Maybe I write information that maybe main regulator use for example TO252 package. This is a note I put either for myself or for other designers. Here I'm telling him this is very important, use the best package available for it. And here of course you draw boxes, basically anything. Just another visualizing tool. And all of these are the same: rectangle, circle, arch, whatever, Bezier, drawing lines, and inserting images and whatnot. So now we have finished using the schematic tool. Let's now dig into some of the hotkeys that we can use to make our life better. Let's, for example, have maybe this one. Now it is already connected. If I drag it with the mouse, it will still be connected. But if I want it out, or I want to move it, I press and I highlight it and press M to move it. Now it can move. Okay, press R to rotate, press X to mirror it on the X axis, press Y to mirror it on the Y axis. Basically anything that's gonna satisfy you. And Control Z, of course, for undo. If you want something else like this, copy, Control C and Control V. But if you want a more faster one, basically Control D to duplicate. Now it's duplicated, and notice that it takes everything that this guy has, the footprint, the 3D, everything, and it uses a J3 directive. What else do we have? A for placing components, basically this tool, and basically everything else is not really important. I find these tools are the best, and these hotkeys are the most used. Mouse is for zooming, mouse wheels. If you press Control and press mouse wheel, you can basically pan like this, and Alt, you can pan on the vertical direction. But basically you're just gonna use like this. And preferences, you can go to preferences, and this is the preferences for the KiCAD software itself, and we can check the schematic editor right here, and to check the stuff that special to it, like the grid that we're using, the component snap into, editing options, annotations, colors if you want to change the colors. I have another theme, and so on and so forth. And now, for example, let's go to maybe file save, and now I have finished everything that I want. I can basically press export, and I can export the drawing to clipboard, whatever. But what I'm interested in is importing, because now you can import other schematics into KiCAD. See, this feature is really nice. I don't use it much. Maybe I open it and copy and paste. Now, with everything is set, I'm gonna explain how to use the net classes the best way. The net classes are accessed from here, for example, net classes, and I have added the power net class. I made it 0.5 millimeter thickness, more than the usual wire, and so on. So if I have something like this 3.3 volts, I'm gonna use this plus 3.3 V. I'm gonna assign it to the power net class. It has to be exactly the same thing. So I'm gonna press OK, and now it became 0.5 millimeter. So with that said, I need to go to this tool right here, the directive label. This label, of course, can make it easier. For example, when I make I choose the power, for example, and I make it look like a circle and something like this, and I can add it, for example, to the 5 volt, and now it becomes like this. When I remove it, it's not there. Okay, so what if I have multiple multiple wiring and multiple signals? I want to assign one net class for all of them. What should I choose? Either I copy and paste this all over the place, or I go to this place right here to draw a rule, basically like that, and I'm gonna include, let's say, all of these. Okay, now I have created a rule area. What rules should I apply? I'm gonna apply this rule. Now suddenly all of these signals are applying the rule to themselves. So this is very important, but to be honest, I don't really use these fancy stuff anymore, or something like that, because it's not really that much. Now let's click save. With that said, we can now conclude the net classes. Basically just draw everything that you need right here, and assign everything that you need right here, whether it's by the pattern or visually using these tools that I explained. And basically that's it. And the wire thickness or everything is gonna be on the schematic only, not on the PCB. Finally, please guys, like, share and subscribe. Check the Thundertronics website and store. Please share this to your colleagues, and this series is gonna continue until it reaches its final videos, where I explain everything that I know about KiCAD to be one global free resource reference on YouTube for anybody that wants to start and excel at PCB design. Thank you for watching guys, and I'll see you in the next tutorial.